I've been told organic chemistry is pretty hard. Students have all kinds of trouble. That's right, today we're introducing organic chemistry. Hit the theme!
Ain't nothing but a chem thing, baby. Two flipped out teachers going crazy. Lancaster is a district that pays me. Unbreakable, so please don't try to break this. But back to the lecture at hand.
Hello and welcome to another episode of Shu Fu Chemin' At Ya. I'm your host Shu, and with me as always is Fu.
What up, nerds?
So Fu, in this unit we're going to talk about carbon and all the different compounds it can form.
Yeah, organic chemistry really is just the study of carbon compounds. Most living things actually are made of carbon compounds, which is where the term organic chemistry comes from. So let's get started. Intro to organic chemistry, a lesson from the organic chemistry unit, obviously. The chemistry of carbon. Organic chemistry is the study of carbon compounds. Carbon can easily bond covalently with 4 other atoms, including other carbon atoms, giving its compounds tetrahedral shapes. This gives carbon the ability to form long chains, branched chains, and even rings.
We've worked with carbon before in the bonding unit. You may remember that it has 4 valence electrons, so it tends to bond to 4 other atoms with single bonds. For example, we've seen CH4 before. CH4 has a tetrahedral shape with the 4 single bonds that carbon forms to hydrogen. Or we can put 2 carbon atoms together. We now have a longer chain, and it's like we put 2 tetrahedral shapes together. Now, if we add another carbon atom, we get a 3 carbon chain. So now our chain is longer, and we can just keep adding carbon atoms to make chains as long as we want. We can also have double bonds between carbon atoms, or triple bonds between carbon atoms. In addition to having long chains, we can form closed chains, otherwise known as rings. All of these structures show just how versatile carbon is. Let's review covalent network compounds. Some carbon compounds are covalent network solids, like diamond and graphite. They do not have distinct and separate molecules. Instead, they have a continuous array of covalent bonds. These solids have very high melting and boiling points since bonds have to be broken in order to separate the particles, not intermolecular attractions since there are no molecules.
Molecular compounds. Most carbon compounds are molecular liquids or gases, like ethanol or propane, respectively. They have low melting and boiling points since intermolecular attractions between separate molecules have to be broken. These attractions between molecules are much weaker than covalent bonds.
Even when compared to other molecular compounds, carbon compounds have weaker intermolecular forces. This is due to carbon compounds tending to be very nonpolar with weaker London dispersion forces, unlike an inorganic molecular compound like water, which is very polar with hydrogen bonds.
If you take a look at the images to the right, the one on top is a molecule called ethane. We have 3 molecules drawn here. Now they are very symmetrical. Now symmetrical molecules are nonpolar, and when they're nonpolar, they have weak intermolecular or London dispersion forces. So these are not held together very strongly, which is why this is ethane gas. Ethane gas is a major component of natural gas. On the bottom, we have water molecules. This one should look familiar by now. Water is very asymmetrical. Asymmetrical means that we have a polar molecule. Now this one has H's bonded to O's, so this one has an intermolecular attraction of hydrogen bonding. This is a stronger intermolecular force, which is why water is liquid. Also, due to most carbon compounds' non-polar natures, they are generally insoluble in polar solvents like water. Remember, like dissolves like? Even when certain organic compounds dissolve in water due to being slightly polar, like ethanol, they are non-electrolytes, no ions to conduct electricity.
You may remember from the solutions unit that oil and water are immiscible liquids. This is because oil is a non-polar organic liquid and water is a polar liquid. This is why the two of them don't mix, because they are not like each other in terms of polarity. Hydrocarbons. Hydrocarbons are a class of organic compounds that contain only carbon and hydrogen. Get it? Hydrocarbons, only carbon and hydrogen. There are three major series of hydrocarbons: alkanes, alkenes, and alkynes, found on Table Q. A molecular formula gives the atoms and their numbers, whereas a structural formula shows the arrangement of atoms by representing bonds as lines.
So we're going to spend the rest of this lesson going over Table Q in detail, but let's introduce it first. So Table Q, the homologous series of hydrocarbons. The first column gives you the name, so we've got the alkanes, alkenes, and alkynes. The second column gives you the general formula. Now, the general formula is a way to figure out what the molecular formula is for each one of these. Note, N is the number of carbon atoms. They also give you some examples of some names and structural formulas. All right, we're going to first look at the alkanes. Shu, I'm going to have you help me out. Sound good?
Sounds good.
All right, according to Table Q, what is the general formula for an alkane?
All right, so under general formula, it says CnH2n plus 2.
Very good. All right, what I want you to do is pick a number between 1 and 10.
Let's go with 3.
Okay, so we're going to have an N value of 3. And if you look at the bottom of Table Q, what does N value mean?
Oh, that's the number of carbon atoms.
Okay, so then what would an example of a 3-carbon alkane be?
Okay, so obviously it would be C3 for the subscript for carbon. But then for hydrogen, I actually have to plug the 3 into 2n plus 2.
Very
So it'd
good.
be 2 times 3 is 6, plus 2 is 8, so there'd be 8 hydrogen. C3H8 would be the molecular formula.
Okay, very good. Now this is an alkane. We can use Table Q again. We can take a look at the examples. What type of bonds does this contain?
It looks like it contains all single bonds.
Okay, very good. All right, and finally we're going to talk about whether this is saturated or unsaturated.
I have no idea.
Okay, well, we're going to look at the type of bonds we just wrote down. What did we say this all contains?
Single bonds.
Single saturated,
Single saturated.
single saturated.
Single saturated. So what does that mean?
That means that we have all single bonds. That's one way of looking at it. Or we have bonded all the possible hydrogens we can to this chain.
Okay, so it's like it's saturated with hydrogens.
Yeah, remember, like a saturated solution can't hold any more. This saturated hydrocarbon can't hold any more hydrogens.
Okay.
How to draw the structural formula from the name. Use Table P to find the number of carbons. Draw the number of carbon atoms in a line and bond them to one another. Add hydrogens as needed, making sure that each carbon has 4 bonds surrounding it. Table P organic prefixes. They're pronounced as follows: meth, eth, prop, bute, pent, hex, hept, oct, non, dec. Okay, ladies and gentlemen, we're going to draw an example of butane for you. Shu, are you ready?
I'm ready.
Okay, so we're going to use Table P to find the number of carbon atoms according to the prefix in this name.
All right, so the prefix is bute, and according to Table P, bute means 4 carbon atoms.
All right, so this has got 4 carbon atoms. The next step is to draw the number of carbon atoms in a line and bond them to one another.
Okay. Got it.
All right, so now that lastly, we're going to add hydrogens as needed, making sure that each carbon has 4 bonds surrounding it.
All right, so this would need 3 more lines around it to get 4, so that's 3 hydrogens. These 2 carbons already have 2 lines, so they'd only need 2 hydrogens each. And then this one on the end again would need 3 hydrogens.
Very good. How to name from the structural formula. Count the number of carbon atoms. Use Table P to determine the prefix. Add the ending ANE. All right, ladies and gentlemen, we have an example here for you. Shu, are you ready?
I'm ready.
All right, let's take a look at what we got.
That doesn't look like a structural formula to me.
All right, this is actually a condensed structural formula.
Wait. Let me write that down.
Okay. Now, a condensed structural formula is exactly what it sounds like. It's just a condensed version of the structural formula. So it still shows all the atoms in the order of the chain. It just doesn't show any bonds.
Okay.
All right. So the first thing we're going to do is look at that first carbon. Now, I like to look at the carbons like pages in a book.
Okay.
So each carbon in the chain is like a page of the book.
Okay.
So everything that follows that carbon is something that's on that page.
Okay.
Right? So the first carbon, what do you see right after that first C?
It says H3. There's 3 H's,
So
right?
that means that there must be 3 H's bonded to this carbon.
Okay. I'm gonna do that then.
And after the H3, what's the next thing you see?
A carbon.
So this is the second page. So this is a continuation of that chain.
And I gotta connect the carbon.
Okay?
Okay.
So then what is after that second C?
2 H's.
So there must be 2 hydrogens on this carbon.
All right, and it kind of continues like that. I think I'm seeing the pattern here.
Very good.
So CH2, CH2, another CH2, and then on the end, I've got CH3. So that looks more like a structural formula to me.
Yep, this is a structural formula, but we have to name this.
Right, we're not done yet.
So we're going to count the number of carbon atoms that we have in our chain here.
All right, so it looks like I've got 1, 2, 3, 4, 5.
Okay, we're going to go to table P and we're going to figure out what is the prefix for 5 carbon atoms.
All right, so looking at table P, 5 is pent. Pent.
Okay, and we've been doing alkanes. We know this is an alkane, but remind our students why this is an alkane.
It has all single bonds, right?
Very good. So this is going to end in ANE.
All right, so pentane.
Very good.
All right, next we're gonna look at alkenes. Foo, you're gonna help me out. Sound good?
Yeah, sounds good.
All right, let's start with table Q. What's the general formula for alkenes?
All right, so on table Q, it is CnH2n.
All right, let's make an alkene you like. Number 1 through 10 for our N value.
2.
Sounds good.
So that means C2, that's 2, and then just 2n, so H4.
C2H4 looks good. All right, so looking at table Q and the examples on the slide, what would you say about the bonding in alkenes?
It looks like on table Q, alkenes have a double bond.
Very good, it has 1 double bond. So based on that double bond, do you think it's saturated or unsaturated? Actually, you know what? What did saturated mean?
Saturated single bond. Saturated single bond.
Good, so does this have all single bonds?
It does not. It has a double bond.
So what do you think that makes this?
It must be unsaturated.
Unsaturated, very good. So we're unsaturated with hydrogens. We don't have the maximum number of hydrogens around each carbon. It's like we took them out to put in the double bond. How to draw the structural formula from the name. Use table P to find the number of carbons. Draw the number of carbon atoms in a line and bond them to one another. Add a double bond on the carbon number indicated in the name. Add hydrogens as needed, making sure that each carbon has 4 bonds surrounding it. All right, we're gonna do an example drawing the structural formula of 1-butene. You ready, Foo?
I am.
All right, so it's important to note that every part of the name has its purpose. So it's our job to just break it down. So first we're gonna use table P to find the number of carbons. So what are we gonna look at for that, Fo?
We're gonna look for a prefix, and I see bute right there.
All right, so according to table P, what does bute mean?
That means 4 carbon atoms.
All right, so we're gonna draw that number of carbon atoms in a line and bond them to one another.
Okay.
All right, next we're gonna add a double bond on the carbon number indicated in the name. What part of the name indicates that carbon number?
All right, so it must be this number out in front here, the number 1.
Good, so that means we're gonna put it on carbon number 1.
So just from left to right.
From left to right works.
Okay, so then it must be on this first carbon there.
Good, now we have our double bond, making it an alkene. Finally, we're gonna add hydrogens as needed, making sure that each carbon has 4 bonds surrounding it. Now be careful, on that first carbon, it already has 2 bonds.
Okay, so it only needs 2 more then.
Good. What What about that second carbon?
Ooh, this has got 3 already, so it just needs 1.
Good.
Okay, and then this one needs 2. And the last one needs 3.
Good. And it sort of seems like we're missing hydrogens. Again, this goes along with this being an unsaturated hydrocarbon.
Okay.
How to name from the structural formula. Count the number of carbon atoms. Use table P to determine the prefix. Add the ending ENE. Write a number with a dash in front of the name, indicating the lowest carbon number that the double bond is touching, only for 4 or more carbon atoms. All right, we're gonna do another example. Are you ready, Fu?
I am.
All right, let's take a look at what we got.
Looks like we have another condensed structural formula.
All right, yeah, so we wanna draw the structural before we name it. All right, so let's break it down.
Okay, so the first page of the first carbon has 3 hydrogens on it.
Good.
And then it's connected to another carbon. There's only 1 H on it. And then the next thing I see is a carbon. But that only gives 3 bonds on that second carbon.
Yeah, it looks like we're missing hydrogens there. And actually, that's because they're implying that there's more than a single bond there. So how can we get both of those carbons to have 4 lines around it without adding hydrogens that aren't listed there?
So this must be a double bond there.
Good, we figured out the double bond. We can think of it as sort of an implied double bond because the hydrogens are missing that would normally be there if this were an alkane.
This carbon needs 4 bonds.
Exactly.
Okay. So then I see a CH2. And finally a CH3.
All right, looks good. We've got our structural formula. Now we're gonna go ahead and name it.
Okay.
So let's count the number of carbon atoms.
I've got 1, 2, 3, 4, 5.
Good, let's use table P to determine the prefix.
That's pent.
Good. Now we're gonna add the ending ENE because this is an alkene with a double bond.
Okay, pentene.
Good. And then we want to write a number with a dash in front of the name, indicating the lowest carbon number that the double bond is touching, only for 4 or more carbon atoms. So we do have 4 or more carbon atoms, right?
We do, we have 5.
So we are going to need a number here.
Okay, so it's touching the 2 and the 3, but I used the lowest one, so I must use the number 2.
Good. 2 and then a dash in the front. And our final name is 2-pentene, the 2 again telling us where that double bond occurs.
Okay. All right, ladies and gentlemen, our last series of homologous hydrocarbons, the alkynes. Shoot, this one gives me all kinds of trouble. I'm gonna need your help. Sound good?
Sounds good.
All right, on table Q, what is the general formula?
It says CnH2n minus 2.
All right, let's pick a number between 1 and 10.
I'm thinking 4.
Okay, so what's the formula for 4 carbons?
We've got C4, gotta plug in the 4 to 2n minus 2, so 2 times 4 is 8, minus 2 is 6, so 6 hydrogens, the formula being C4H6.
Very good. Now looking at table Q, what is indicative of these alkynes?
It looks like they all have 1 triple bond.
Very good. Now lastly, is this saturated or is it unsaturated?
Well, since it has a triple bond, it can't be all single bonds, so it can't be saturated, so I'm going with unsaturated.
Very good. How to draw the structural formula from the name. Use table P to find the number of carbons. Draw the number of carbon atoms in a line and bond them to one another. Add a triple bond on the carbon number indicated in the name. Add hydrogens as needed, making sure that each carbon has 4 bonds surrounding it. Okay, ladies and gentlemen, I have an example here for you. Shu, are you ready?
I'm ready.
All right, good. We're going to draw out 2-butyne. Okay, so just a reminder, every part of an organic compound's name has a meaning behind it. So the first things first, let's use table P and find the number of carbon atoms.
All right, so my prefix is bute. So on table P, bute means 4, right?
Yep, so we're going to draw 4 carbon atoms and bond them all together with a single line in between.
All right, got it.
All right, the next step is to add a triple bond on the carbon number indicated in the name.
All right, well, there's a 2 in the front.
Okay, so where is our second carbon?
So our second carbon is right on here. And so I put a triple bond on the second carbon.
Very good. So the last part here is to add hydrogens as needed. Again, making sure that each carbon has 4 total bonds each.
All right, so the first one is gonna need 3 to have 4 total bonds. Second one looks like it has 4 bonds around it already, so no hydrogens.
It does.
Same with carbon 3, it's got 4 already. And then carbon 4 still needs 3 hydrogens.
Very good. How to name from the structural formula. Count the number of carbon atoms. Use table P to determine the prefix. Add the ending YNE. Write a number with a dash in front of the name, indicating the lowest carbon number that the triple bond is touching, only for 4 or more carbon atoms. All right, ladies and gentlemen, we have one more example here for you. Shu, are you ready?
I'm ready.
All right, we got that good condensed structural formula. Mind drawing it out for me?
Oh, I think I got this time. So I've got CH3, CH2, getting it, and then CH doesn't look right.
All right, we're just missing a couple of bonds here. Remember, carbon always has to have 4 bonds.
Right, looks like it's missing hydrogens, but it must be that there's a double or triple bond in here. So let's see. To get 4 on each one of those carbons, it looks like I need a triple bond. And I think now they both have 4 bonds around them at the end there.
Very good. So we're gonna name this. So we're gonna count the number of carbon atoms.
All right, I've got 1, 2, 3, 4, 5.
Okay, on table P, what's the prefix for 5?
That would be pent.
All right. This has a triple bond, so it's an alkyne, so it's gonna end in YNE.
All right, so pentyne.
Good, and last thing we have to do is indicate where that triple bond is by writing a number with a dash line indicating the lowest carbon atom that it's touching.
Well, it's between carbons 4 and 5, so I'm gonna go with 4. That's a lower number, so 4 pentyne.
Almost, not quite though. We're going to look at this from a different perspective here.
Okay.
Now, if you were to number this from right to left, I know you numbered from left to right, but if you were to number it the other way, from right to left,
Okay.
would your number go down? Would it be lower than 4?
If I number the other way, it's between carbon 1 and 2, and the lower number would be 1, so yeah, that would be different than 4 pentyne.
So in this particular instance, we're gonna have to number from right to left because that triple bond is closest to the right, which gives us a lower number.
So 1 pentyne. So you just have to remember, I could number either way, I just have to get the triple bond with a lower number. So that's how I'm gonna decide which way to number.
Correct. You try. For each of the following, use table Q to classify as alkane, alkene, or alkyne. Then determine if the compound is saturated or unsaturated.
Well, that's gonna do it for today's episode, Introducing Organic Chemistry.
Later, nerds!
Wait. Okay. That's good.
It's a good outtake.
Good outtake. It's not even an outtake. I did it for
I do it for the kids.
for the kids in the outtake roll. Okay. I'm
They-
pandering now.
They do love the
They
outtakes.
do.
They do.
Hydrocarbons. Hydrocarbon. Hydrocarbon. Well, I wasn't informed that I'd be doing your work for you.
Okay, but are you willing to help me out? Nope. Okay, so we're gonna take a look at table Q. And no, we're not, because you're not on table Q, but I am. Alkanes on table Q. Sure, you're gonna help me out. I'm so used to saying it. Sure. All right, first we're gonna take a look at the alkanes.
Wait, you know what? Sorry, I really apologize. This would.
All right, first we're gonna take a look at the alkanes. Sure, are you gonna help me out? Nope. Sound good?
Sounds good.
Okay. Towards the table. All right, we're gonna take a look at the alkanes first. Shu, I'm gonna have you help me here. Does that sound?
Do you consent?
Do you-
Today's episode is brought to you by
TechNeck hands-free device collar. Stream your favorite videos while still talking on your burner phone. Fits most mobile phones and tablets. Now you can keep your hands to yourself.
But we never off, always on till the break of dawn. SCIENCE in the hall they call S-Wing. You know we never wear a tie, like my homies, boys to men, it's so hard to say goodbye.
Like this, that, and this, and it's like that, and like this, and like that, and it's like this.
You're going in low power mode.
Plug and chill to the next episode.